Good afternoon, math students. Hope you guys had a good weekend, and I'm anxious to see your good quiz scores from the other day. And if you don't quite like your quiz score, then we'll talk about what you can do to fix that here in a little bit. But for today, we need to talk about 8.3, which is initial value. Initial value is basically the same thing as the y-intercept. So it's all going to be linear equations that we're focusing in on today, meaning they have a constant rate of change or a constant slope. And we're going to look at them in the form y equals mx plus b. So if y is by itself equal to something else, whatever right there is in front of the x is the slope or the rate of change of the line. Whatever is being added or subtracted at the end is where the line is going to cross the y-axis. So it's considered that's the y-intercept, or what 8.3 focuses on is the initial value, where the line starts. So for the first one, it says which linear function or functions have an initial value of -4. So basically what we're looking for is a subtract 4 at the very end. So example 1 here shows an initial value of 5. So that's not it. Example 2, just need to rewrite it just a little bit so you can see it better. All I'm going to do is flip-flop the -5x and the -4. So y equals -5x minus 4. Remember, if there's a negative sign in front of something, it's the same as a subtraction. So this one right here, since the -4 is being subtracted at the end, this one has an initial value of -4. Over here in example 3, unfortunately, this one does not. This initial value would be 5 because there's a plus 5 at the end. So the answer is 2. On your notes, I should see how you rewrote it for me. And it wouldn't hurt for you to write down that this initial value is 5 and this initial value is 5. So I'm going to be looking for your notes tomorrow. I want to make sure that you have all the important information copied down. Example 2. The graph represents the function described in words below. Write each value or equation for the linear function. And it's going to walk you through step by step, so it makes it really nice for you. Josie has 1.5 cups of water in her watering can already. So that right there should clue you in. Maybe that's the initial value. She fills the can before watering her plants. Water flows into the watering can at a rate of 1 cup every 4 seconds. As soon as you see the word rate right here, that should clue you into rate of change, slope. That's what's happening. That's your unit rate right there, 1 cup every 4 seconds. So as you can see, the line starts right here at 1.5 on the y-axis. So the y-intercept of the line is 1.5. It's also the initial value of the function. Those are going to be the same thing each and every time. The y-intercept is 1.5 and the initial value is 1.5. That's where the line or the function is starting. Now we have to find the rate of change. The rate of change is your change in y over change in x. Don't forget, I think a lot of you have been switching that up. Your change in y over change in x, because we want cups per second, not seconds per cup. We want cups per second, so we put y value over x value. Here's a point here at 0, 0. And it tells you right here, though, it goes up 1 every 4. So 1 cup every 4 seconds. So your slope is 1/4. So I write that there. And for slope and for rate of change, because those are the same thing as well. So now all you have to do is put them together. Y equals 1/4 x plus 1.5. So it's always y equals whatever your slope or rate of change is, x, and then plus or minus the initial value. This time it was a plus 1.5. Example number 3, looking at this graph, what is the rate of change and the initial value for the function? Easiest thing to tell right there is it's crossing the y-axis, the y right there, crossing the y-axis right there at 8. So the initial value is 8. Now we have to find the slope, which is the rate of change. Obviously, as we read from left to right, the slope is going down, so it should be negative. From here to here to here, these are all points. It looks like it's going from 8 down 2 spots to 6, because notice the graph is counting by 2s, 2, 4, 6, 8. So it's going from 8 to 6 is down 2 over 1. So, or you could say it's going down 4 over 2. It doesn't matter. But notice, this x-axis is counting by 1s, and this y-axis counting by 2s. So if I go from here to here, I'm actually going down 2 over 1. Or you could say I'm going down 4 over 2. Regardless, -4 divided by 2 is -2. Don't forget, it's the rise over the run first, the rise first, and then over the run. So down 4 over 2, -4 divided by 2 is -2. Our new function, D equals 125 plus 80N, can also be written as D equals 80N plus 125, models the amount of money in dollars the Zipline ticket cashier has in her cash register after selling N tickets. How much money did the cashier have in the register before she sold any tickets? So basically they're asking for, hey, what's the initial value or the amount that she started with? If you rewrite it in that y equals something times x plus something else at the end form, it's so easy to tell what the initial value is. So distance equals 80n plus 125. All I did was I flip-flopped the 125 and 80n, and both of them were positive, so they stayed positive. Whatever's being added or subtracted at the end is your initial value. So the cashier had $125 already in her register. This is some digits help here, so some questions that you might see. The linear function in the graph models the temperature T after the big temperature T at T hours after noon. So it starts at 12 o'clock and then it's going on in time on a certain autumn day. Find the initial value of the function. What does the initial value represent? So remember, this is the temperature. It's going from 0 on up past 100. And the graph actually starts halfway between 60 and 70, which would be 65. So the initial value, the y-intercept, is 65. Now remember, it said afternoon on an autumn day. So this represents the temperature at noon. And then obviously from there, it's going to continue to drop. So the temperature at noon was 65, and then as you can tell from there, the rate of change is negative. The temperature is going to start to increase. Homework, 8.3 digits online homework. I want you to make sure that all other topic 5 and 8 work is done. I haven't had a chance to look at that over the weekend yet, so you have a little bit of time. Make sure you get 8.3 done. If you did not like your quiz score from the other day, from last Friday, I'm going to assign the retake practice. I would love it if you would get started on that. We need to get those retaken this week because next week we need to start focusing on your big topic 5-8 test. So I'd really like to get topic 5-8 quiz retaken as soon as possible. If you want to retake, the retake practice is already out there on Digits. Hope you guys had a good weekend. I look forward to seeing you tomorrow. Please be good for Mrs. Allen and make sure you have a completed note sheet.